Dear students, here I'm making small videos of the third module of engineering physics subject. The topic is Maxwell's equations, and I'll be uploading this in our college YouTube channel. You go through them and get to know these topics and study them well. If you have any doubts, you can get back to us. To start with, I'll be discussing some of the fundamentals of physical quantity. You know that physical quantities are divided into two types. One is the scalar quantity, other one is the vector quantity. Scalar quantity is one which has only the magnitude. The examples which you can give is the mass, work, temperature, etc. And a vector quantity is a quantity which has got both direction as well as the magnitude. The examples are velocity, force, torque, and so on. Any vector can be represented by a symbol like vector A is equal to the modulus of vector A and AR cap, where AR cap is a unit vector which is along A. And in vector calculus we have got some of the topics like vector multiplication. So there are two types of vector multiplication. One is known as dot product. So when I have a vector A and vector B, so this is a vector A and this is the vector B, then A dot B is given by modulus of A into modulus of B into cos theta, where theta is the angle between the two vectors. So this is known as the dot product. Similarly, there is one more type called vector product, or it's also known as cross product. So vector A cross vector B is equal to modulus of vector A into modulus of vector B into sine theta into a vector n cap. Here, if I can write this as a vector A and this is a vector B, this is the angle between them, and the A cross B is along a direction which is perpendicular to the plane carrying A and B, and here n cap indicates the direction of A cross B, and A cross B once again it's a vector, whereas A dot B, the dot product, or it's also known as the scalar product, A dot B, it is the result is a scalar. Now let us see some of the fundamentals of vector calculus, out of which the one operator called del operator. So this is a mathematical operator in vector calculus for doing some operations. So del is given by, it's a vector operator, it's given by del is equal to d by dx of ax cap plus d by dx dy of ay cap plus d by dz az cap, where ax cap ay cap and az cap. They are known as the base vectors. And in other coordinate system like cylindrical coordinate system and all, del has got different form. Now let us see what is gradient. Gradient V. Imagine in a space where all points are having same potential. All points are having same potential. Then there can't be any electric field. Electric field will exist only when there is a potential difference. That's why the rate of change of electric potential with respect to distance, it tells the intensity of the electric field. So electric field can be written as it is minus dV by dr into AR cap. So here AR cap, it is a unit vector along the vector E, and minus sign indicates that the electric field is always directed along the decreasing electric potential. And we can expand this as d by dx of V into AX cap plus dV by dy AY cap plus dV by dz AY cap. So this is how we can write, and we can take out this V. It becomes minus d by dx AX cap plus d by dy AY cap plus d by dz AZ cap into V. So this, you know that this is known as a del, minus del V. This we call negative gradient of V, and this is equal to the electric field. Now let us discuss some of the fundamentals of electromagnetic theory, one of which is divergence. Just imagine a field, a vector field A. There is a vector field, and imagine a point, say P, and think of a small elemental volume there. So it is del V. Then the divergence of the vector A at a point P is the outward flux per unit volume as the volume del V tends to 0 around that point. Or it can be written as divergence of A as limit del V tends to 0. So it is the surface integral of vector A ds by del V. Or this is simply written as it's d by dx of Ax plus d by dy of Az plus d by dz of it's Ax here, Ax d by dz of Az. So this is the divergence of the field A. Now what is the significance of this? Physical significance of divergence. See here I have a positive charge. Then the electric field lines are going away from this. And if you take up the divergence here, it is positive. If you imagine a negative charge, then the electric field lines are converging like this. And if you take up the divergence here, it is negative. Imagine the field lines are parallel. So when the field lines are parallel, then here there is no divergence at all. It is 0. So what is the physical significance of the divergence is? It gives what is the amount of field coming out of a given point, or what is the magnitude of the field emanating out of a given point. So that is what the divergence is. And if the divergence of any field is equal to 0, that means that particular field we call it as a solenoid. So that's in a solenoid, the magnetic field is in the form of curl. So whenever there is a curl, field curls, it doesn't diverge. That's why divergence of a curl is always equal to 0. Next we'll see what is curl. Curl of a field, curl. So curl means it is circulation. So imagine, as I said, when there is a conductor carrying current, around that the magnetic field is curling. And if you imagine a vector, such vector like vector A, so the curl of a vector field A means it is the maximum circulation per unit area as the area shrinks to 0 around that point, say P. So it can be written as the curl is del cross A is equal to, as limit del here the surface tends to 0, and it is a line integral of vector A dl by here it's del S. So and into a vector, and I can call this as A n cap. So del cross A is along the direction which is normal to the surface del S, and del S is chosen in such a manner that its orientation in such a manner that the circulation must be maximum in that particular area del S, and an cap is perpendicular to or normal to this particular surface. Or this also in simplified form is written as ax cap, ay cap, az cap, del cross A, and it here d by dx, d by dy, d by dz, and it is ax, ay, az. So this is this is curl of A. So what is the significance of physical significance of curl of any vector A? So curl of any vector A means what is the magnitude of circulation of that particular vector. You can imagine, as I said in the beginning, when a current carrying conductor, around that there is a circulation of magnetic field. You can write like this. So there is a circulation of H magnetic field like this. If the magnitude of the circulation is, or intensity of magnetic field is high, then it is indicated with a larger arrow marks. Only difference is the intensity of the magnetic field. And here the curl is the magnitude is less, it's more here. And if you imagine a field which is parallel, and here if you take, there is no curl at all, that means curl of such vector field is equal to 0. So the significance is, as I said, how much the field curls, the vector field curls. So that is given by this particular curl of the vector A. And whenever the curl of any vector is 0, we call such a vector as a rotational vector. So these are the fundamentals to understand Maxwell's equations topic better. So I conclude here with these discussions. Thank you.